parentheses. First grade. How did the double negative change the problem? So now we're looking at some problems where we're subtracting a negative amount. Once again, I'm going to think of this as the opposite. I always want to go right. I'm doing the opposite, then the opposite again. So if I have Larry, I'm going to start at 2. I want to go the opposite. I want to go left, but now I'm going the opposite again. So now I'm going right 4. 1, 2, 3, 4. Larry ends up at a positive 6. 3 minus negative 5. So I start at 3. This first minus tells me I want to go left, but then I'm going the opposite again. So I'm going right 5. 1, 2, 3, 4, 5. So I end up at a positive 8. When I look at these problems, something's jumping out at me. 2 minus negative 4 is 6. Well, what do I know about 2 and 4 to get 6? I can add them together. Does the same thing hold true here? 3 and 5. How do I make 8? Well, I could add them together. I wonder if that's going to hold true over here. Let's take a look and see. I'm going to start at negative 2. Left, right, 4. 1, 2, 3, 4. Becomes a positive 2. So let's see if that pattern held true. Negative 2 plus 4. Is that equal to 2? Negative 2 to the right 4. Sure enough is 2. So I wonder if I even need to do this problem. If I'm looking at it, what I'm basically done is said that instead of 2 minus signs, I've just made one big plus sign here, one big addition problem. So if we do that here, negative 3 plus 5 would be a positive 2. And let's try that and see what happens. So if I get rid of this, go back to my original problem, what it was. I'm going to start at negative 3. Left, right, 5. 1, 2, 3, 4, 5. I end up at 2. And negative 3 to the right 5 is going to be 2 again. Let's try some harder problems together. So once again here, we're going to be doing some other problems. Anytime I see parentheses, I'm going to want to do what's in those first. So that's a quick review of order of operations, which we'll be doing in more detail here shortly. But if we're just looking at these problems and I wanted to simplify them or work them out, I would do the parentheses first. So we'll do that first. So I have 4 plus 2 to the left 3. I could draw my number line if I needed to. I am going to the left 3, so I'm just going to do 2. I know I got to go left 1, 2 spots, 3 spots. So where do I end up? At negative 1. And 4 plus negative 1 is going to be 3. To the right, to the left, 1. Taking a look at our next problem, I have negative 5 minus 4 plus 2 is 6. And negative 5 to the left 6 means negative 11. And 6 minus 3 to the left 7. So if I imagine on my number line, I'm at 3. I'm going this direction, a total of 7. Here was 0, so where do I end up? At negative 4. Moving in this direction 7 spots. So it's at negative 4. And what did we say about this when we have this here? It really is just 6 plus 4, which is 10. Alright, let's continue moving on. Let's do a quick review of the order of operations here. What we're going to be focusing on, because we're really looking at integer operations, is just the multiplication division. We know we need to do what's in parentheses first. So we're going to be looking at multiplication and division, followed by addition and subtraction. We always do these in partner from left to right, just like we would read a book, so from left to right. And we always do our multiplication division first, and then our addition and subtraction. We always starting, though, within parentheses. You're going to see lots of parentheses in the problems that follow. So let's take a look here. We'll do a couple together, and then I'll have you try some on your own. So let's take a look at this first one. I'm looking at negative 7 minus 1 plus 6. I'm going to want to move from left to right, so negative 1, or negative 7 minus 1, negative 8. Negative 8 plus 6 means to the right 6. Leaves me at negative 2. And looking at our second problem, it's multiplication and division, so I'm just going to do that from left to right. So I start with 7 times 4 is 28. 28 divided by a negative 2. Well, I need to remember those rules about multiplying integers. So anytime I have just a positive times a positive, so something like 7 times 4, that's going to give me a positive 28. But if I have a positive and a negative value, whether it be first or second, I'm really taking the opposite of this positive operation here. There's like a negative 1 involved. So those are going to both be negative amounts. So they're both going to equal negative 28. And anytime I'm doing a negative times a negative, I might think about this as a negative 1 times negative 1 times 7 times 4. And these negatives really just are the opposite. So I have my 7 times 4, which is 28. The opposite. Well, what's the opposite of 28? Negative 28. And the opposite of negative 28 would be 28. So negative times a negative is a positive. At the end of this lesson, I might give you a cute way to remember that, help you just recall those facts. So we have a positive divided by a negative. Same rules hold for the opposite operation, multiplication, which is division. So it's a positive divided by a negative, means our solution will be negative. 28 divided by 2 is 14. So it's negative 14. Alright, let's take a look here at these two problems. I'll give you a few seconds. Please pause the slideshow at this time to try these on your own. I'll be back with you shortly. Okay, hopefully you were able to have some success with these problems. So let's start within the parentheses here first. So I have negative 9 divided by 3 is what I'm going to want to do first. Oops. Let me just start this problem over here. So I have negative 9 divided by 3 divided by 2 divided by 9 times negative 6. So negative 9 divided by 3, just looking at that problem first, negative divided by a positive is going to give me a negative 3 divided by 2 divided by 9 times negative 6. So if I'm looking at this, negative 3 divided by 2, I may just leave it in fraction form at this point. It's already simplified or reduced, where you might be familiar with. Divided by 9 times negative 6. Now, I might want to do this multiplication here, but I do need to remember I'm working from left to right. So I'm going to do the division first. So just to work on a side note here, if I'm doing negative 3 over 2 divided by 9, it's really 9 over 1. Any number can be written over 1 for fraction form. And you may recall that you can invert and multiply this. And you're just multiplying across the top. Negative 3. 2 times 9 is 18. And negative 3 over 18 can actually simplify to negative 1 over 6. So really what I have now, my next step here, is I have a negative 1 over 6 times a negative 6. Negative times a negative is a positive. I'm going to move over. So I know my solution is going to be positive, and 1/6 of 6 is 1. And to look at that, I might do this times negative 6 over 1. Negative times a negative is a positive. And that's 6. 6 times 1 is 6. 6 over 6 is 1. Looking at our second problem down here, moving from left to right, I'm going to save this addition till last because I've got multiplication. Anytime numbers are just next to each other like this, like in the previous problem, that is just multiplication. So negative 1 times 3, it's a negative times a positive. is a -3. And I'll just write the rest of the problem out. -3 times 5 is -15. And I have a -15 plus a -6, means to the right, moving to the left now, the opposite. So -15 take away 6 more is -21. Here are two other problems for you. We have several problems today that you're going to be working on, a few more slides. If you've printed out the slideshow, you know that. So if you could please just work ahead and work on these two problems. I'll give you a few moments. You may want to pause the slideshow. Okay, coming back, let's work on this problem together now. I have -9 divided by 3 divided by 9 plus 9 plus -9. So I'm going to work inside this parenthesis here first, starting from left to right. So I have -9 divided by 3. So I might just write that like this. Divided by 9. That's still all in parentheses. I'm just rewriting the problem in a more friendly way. One way that I might be able to attack it. If I have -9 divided by 3, one thing that's jumping out at me is this is just -3 divided by 9 plus 9 plus -9. This is going to simplify to -3 over 9 plus 9 plus -9. And -3 over 9, if I move up over here, I'm sorry I'm running out of room, but it becomes -1 over 3 is what that can simplify to, plus 9 plus -9. One thing I noticed is I could add the 9, then add the -9, but I also noticed that 9 plus -9, or addition, the order of addition does not really matter. That's the commutative property of addition. So I could do this first, and 9 plus -9, or 9 take away 9, is going to be 0, so my solution would be -1/3, and I could be done right there. However, if I wanted to work this problem out, I'll come over here. -1/3 plus 9 plus -9. This is not going to necessarily be the nicest looking problem. If I'm at -1/3 plus 9, that becomes 8 2/3 plus a -9. So now I just take away that 9, I just add it, and I'm back at -1 over 3. So two different ways to look at the same problem. You'll notice the more practice and more times that we work with problems, we'll kind of look for these patterns that jump out at us, nice ways to simplify our problems for us. Let's work parentheses within parentheses. We always start with our parentheses here. This is going to be a multiplication between these two. You might recall that this can become our big plus sign here. So if I'm looking at 5 minus -8, that I might think about that as, whoops, sorry about that. I might think about that as 5 plus 8 times 9, which is 13 times 9. And 13 times 9, hopefully you have your calculator and you've already done this, would be 117.